Hello everyone, welcome back to our Lee County Library Science Club. It's great to have you with us again this week. Just a reminder, please make sure you have your parents' permission and some supervision when you're doing these experiments. Now this week, we are going to have a little fun. We're going to draw a picture. We're going to teach it to dance. Dance, baby, dance. Yeah! Sorry about that. I don't know what came over me. Science, back to the science stuff. It's very serious stuff here. Right, science. Anyways, when we're drawing a picture, one of the things we use is a marker, right? And markers are a very simple, normal part of our everyday life, but they actually are a pretty cool demonstration of our modern chemistry and how we use that chemistry in all areas of our lives. So when you're drawing with a marker, what are we actually doing? Well, we know there's ink inside, right? And we are getting the ink out of the marker and spreading it on the paper or whatever other surface we're writing on. So what is the ink? Well, it has three parts to it. It has a colored pigment, a solvent, and what's known as a polymer. To put it simply, pigment is color, but color is a concept that in the chemistry and physics world is way more complicated than we may realize in our everyday lives, okay? Because when you're looking at a color, what you're actually seeing is a certain wavelength of light that is being reflected back from that substance. Like my shirt is a nice bright red. What that means is the light shining down on me has all of the wavelengths of the visible spectrum in it, but my shirt is absorbing all of the yellow and green and blue and purple, but it's reflecting the wavelengths for red, which is a pretty bizarre concept. Like these black markers, when I draw something in black, that means it's actually absorbing almost all the light that's hitting it. Okay, it's not quite absorbing all of it because we definitely can still see it, but it's absorbing enough that we don't see any colors reflected back to us because it's absorbing almost every wavelength possible. And so when we say we put a pigment into the ink, well, we've just introduced a material that changes how the light is reflected from whatever you're drawing on. It's pretty complicated, huh? It sounds pretty complicated at least. And you don't obviously need to worry about that when you're just coloring a picture, but I think it's pretty cool to know. Now the second part of ink is the solvent. And that's something we've talked about a few times. A solution, right, is when you have different things dissolved into a solvent. Now in ink, in a lot of cases, it's going to be some form of alcohol, like isopropyl alcohol or ethanol. But in some pens, it's like a gel, a silicate gel, or it might be water even in some. But the solvent is there to hold the pigment with the last part, which is the polymer. Polymer is a very general term for materials made of a long chain of repeating molecules. And we see polymers everywhere in our lives. Most plastics, wood, rubber, glass, all of these things are polymers, which means they are one molecule that is bonded together and repeated in a long chain, and it gives some specific properties depending on what that molecule is. Now I have two different markers here. I have one dry erase marker and one permanent marker. The big difference between these two markers is that polymer. In a permanent marker, they would use an acrylic polymer, which means the base molecule is acrylic acid, which is the same thing that's used in like plexiglass. And that acrylic molecule is sticky. So when we say it's permanent marker, it's because it has that acrylic polymer that takes the pigment and sticks it to whatever you're drawing on. Now, on the other hand, with this dry erase marker, the polymer is a silicon-based polymer. And what that means is that instead of being sticky, it's actually very slippery. And so when you draw with a dry erase marker on a material that is non-porous or doesn't have any holes and gaps for the ink to flow into, when you draw on that surface, the silicon polymer holds the pigment right on the surface of whatever you're drawing on, and it doesn't stick to it. And that means you can just wipe it off, right? So that is how chemistry can affect our simple everyday lives. So what you'll need for our demonstration today, you'll need one dry erase marker, one glass bowl or plate. Make sure it has a nice smooth bottom, not something with designs in it. And then we just need some water. And what we're going to do is we're going to draw a picture on the bottom of our glass bowl with our dry erase marker. And then due to the nature of the solution of the polymer, the silicon polymer, and the pigment, we're actually going to be able to remove the picture from the bottom of the bowl with the water, and it can actually float around in the water. It's really cool. Let's get started. Now, like I said, we're going to start by drawing a picture on the bottom of our bowl. You can feel free to draw whatever kind of picture you want. I'm just going to draw us a little guy who looks like he might be ready to do some dancing. Okay, he look like he's ready to do some dancing? Yeah. Now, as we said before, this has a pigment, a solvent, and a polymer in it. And for a dry erase marker like this, it's almost always the solvent is going to be an alcohol, like an ethanol or an isopropyl alcohol. And that's why it dries really fast. You can see it was a liquid when we drew it on there, but now that it's had a chance to dry, it's actually a solid. Okay, because that alcohol evaporated, and what's left is the silicon polymer bonded to the pigment. And we just have a solid picture on the bottom of our glass. We need to tilt it to the side a little bit, okay? And then we're going to fill some water in the side. Now, once we've got a good amount in there, we're going to slowly tip it sideways. We're going to do it nice and slow so that the water can get under that pigment solid, okay? We want to do it slow so it doesn't tear it as it does it. All right, you see that? Now, you can see our little guy is actually floating around in the water, and we can make him dance. If you set it down, you can kind of move him around, push him around with your finger. He moves around a little bit. See that? And like we said, this is the silicon polymer bonded with the pigment, gives us a picture that we can actually move around. Feel free to try it with different colors and different pictures. See if you can come up with something that might look really cool, like this beautiful sunset drawn by our very own Miss Chenille. Again, we want to do it slowly. Oh. So just to reiterate what's happening here, inside the marker, we've got a liquid solution of black pigment and silicon polymer dissolved into an alcohol. And this is most likely ethanol. And then when you actually draw it onto the glass, that liquid is coming out and the ethanol is evaporating away. But it leaves behind the silicon polymer bonded with that pigment. And water, as we know, is polar, and so the silicon polymer doesn't mix and doesn't dissolve into the water, and so it actually just floats there. And the glass is such a smooth material that there's not really any bumps or ridges for the ink to stick into, and so it can lift right off of the glass and stay together as one whole picture. This was just something to show you guys that chemistry and physics are everywhere around us, okay? This little dry erase marker, probably used in your classroom at school every single day. There's a lot of cool chemistry going on with this little dry erase marker. Thank you so much for watching. We appreciate it, and we'll see you again next time. Bye!